Please go ahead, start.
Bismillahirrahmanirrahim. Excellencies, distinguished speakers, esteemed colleagues from ComSet Centers of Excellence and member states and partner institutions. Assalamu alaikum, good afternoon and good evening. My name is Dr. Huma Bloch. I will be moderating today's session. It is my distinct honor to welcome you all to this virtual high-level forum on quantum science and technology strategic pathways for the Global South. This event is actually being held to commemorate the International Year of Quantum Science 2025. And this forum is being held to provide a timely platform to deliberate on how quantum science that was once the subject of theoretical exploration is now becoming a transformative driver for innovation, competitiveness, and sustainable development. We are grateful to all of the participants for their participation, which demonstrate the collective commitment of the Global South to be at the forefront of this frontier science. Without any delay, let's start the proceedings of the day. First, I would like to invite the Executive Director of ComSet, Ambassador Dr. Mohammad Nafiz Zakir, to deliver the opening remarks. And I must say that Ambassador Zakir's leadership has been very pivotal in positioning ComSet as a bridge between science, policy, and development for the Global South. The platform is yours, sir.
Thank you very much. Bismillahirrahmanirrahim. I'm so delighted to see all my friends here. Honorable Professor Marcelo Nobel, Executive Director, the World Academy of Sciences. Honorable Professor Dr. Galileo Violini, Director Emeritus, International Center for Physics. I also have Professor Dr. Zafar Gedek, and then Professor Orhan, Dr. Hamid Raza, Mohammadi Khoshi, University of Isfahan, Excellencies, distinguished scientists and experts, colleagues from ComSet's member states and centers of excellence, ladies and gentlemen. Assalamu alaikum and good afternoon. Somewhere it is very, very early morning. I warmly welcome you all on behalf of the ComSet's fraternity to this high-level forum on science, quantum science and technology. The theme topic is strategic pathways for Global South. The event is aimed at discussing significance of science as to how it started to change our life in the past, impacts our present, and would even inevitably shape our future. The deliberations shall envision the Global South as a co-architect of the quantum revolution rather than be a follower. Distinguished scientists and experts, and my very dear friends, the eminent architect of modern physics, Professor Abdul Salam, whose vision underpins both ComSets and TWAS. Professor Salam, the first Pakistani Nobel laureate in physics, made fundamental contributions to quantum electrodynamics, QED, transformed physics by unifying electromagnetic and weak nuclear forces, a breakthrough that earned him Nobel Peace Prize and helped establish the very foundations of the particle theory. In 1979, on the occasion of the award of Nobel Prize to Professor Salam, he remarked, "All physicists believed the deeper we seek, the more is our wonder excited, and more is the dazzlement of our gaze." This indeed remains so valid today and shall remain so for the times to come. It was Professor Salam's conviction that science is a shared heritage of humankind and must be mobilized for development of all, which was instrumental in the establishment of TWAS in 1983 and ComSets in 1994. Both organizations were dedicated to empowering the Global South through scientific cooperation. Today's forum carries forward Professor Salam's vision into the era of quantum frontiers. Ladies and gentlemen, quantum science is a strategic frontier reshaping the national security, industrial competitiveness, and scientific leadership. Quantum communication networks provide unbreakable security, quantum sensors enabling unprecedented precision in environmental monitoring, and also in the communication network. Realizing the transformative implications of quantum science, the Developed countries like the United States of America, Canada, the United Kingdom, the Netherlands, the European Union, and China have all established robust national quantum initiatives with significant investments. They are all in tough competition with each other to secure intellectual propriety, and talent and market leadership in this domain. The question to ponder is whether the unprecedented pace at which various technologies are emerging and making deeper and deeper ingress into our sphere of our life carry risks such as digital divide and may now be resulting in the shape of quantum divide. Much like the digital divide of the past decade, it threatens to marginalize developing nations. But here lies our opportunity. The global south has edge in human resource, and it need not replicate the global north's trajectory. Instead, we can outpace by pooling our resources, it is my conviction, and investing in our human resource through capacity building, skill development in software, algorithms, and applied layers of quantum technologies. These are the areas where creativity, contextual innovation, and collaboration matter as much as the capital. Now, honorable scientists and experts who are with us today, the global South nations have more than two-thirds of world's youth. This is a great strength that we possess, a reservoir of creativity and scientific curiosity that needs to be nurtured. Our urgent scientific societal challenges, from food insecurity to climate vulnerability, provide fertile ground for deploying quantum solutions in agriculture, water, and energy. Institutions like ComSets and TOAS, they can play a catalytic role in this regard. Through South-South and triangular cooperation, we have developed collaborative mechanisms that allow us to pool resources, share expertise, and build collective capacity. The ComSet's 27 member states span 3 continents, connecting policymakers with centers of excellence in diverse scientific fields. On the other hand, TOAS also adds a formidable global network of scientific excellence. Together, we form a bridge between knowledge and development, between the vision of Professor Abdul Salam and the needs of our societies today. Quantum technologies, moreover, are uniquely aligned with the Sustainable Development Goals. All of us are well aware quantum sensors can detect greenhouse gases with unprecedented precision, enhancing climate modeling and resilience. Given its relevance to genomic sequencing, quantum simulations promise rapid development of new drugs and personalized therapies in healthcare. We are pursuing that also on our part. Quantum algorithms can optimize renewable energy grids, fertilizer use, and irrigation systems, critical for agriculture-dependent economies. And ladies and gentlemen, and quantum communication offers secure digital infrastructure vital for financial systems, governance, and citizen trust. These are not distant dreams. They are emerging realities, and Global South must claim its stake in it. In pursuit of this vision, ComSet has already ventured into frontiers areas aligned with our member states' needs, from training in artificial intelligence, scanning electron microscope, nanotechnology, cybersecurity, mobile apps, ERPs, and software quality assurance. We are keenly making efforts towards collaborative research in precision agriculture, genomic sequencing for precision medicines. Our next frontier must be quantum capacity building, establishing pilot projects, and fostering collaboration with leading international partners while keeping the Global South's priorities at the center. The proclamation of 2025 as the International Year of Quantum Science and Technology provides us a historic opportunity. For the Global South, this is a call to action, to participate, to integrate quantum technologies into national science strategies, to establish joint South-South programs for training and research, to engage industry, startups, and youth in building innovation ecosystems, and to ensure that the quantum future is not only about technology, but also about equity, sustainability, and shared prosperity. Ladies and gentlemen, we should unite our strengths, align our policies, and nurture our youth to the benefit of all. This, I believe, would be the most befitting tribute to the legacy of Professor Abdul Salam worldwide. I conclude by expressing my profound thanks to the Honorable Professor Nobel, Professor Galileo, and other distinguished scientists and experts with us for the gracious participation and sparing precious time for sharing their valuable knowledge to enlighten the audience with us today. My profound appreciation for the hard work put in by my team, our ComSets team, Dr. Mavish, she is Director IPOs and Head of the Center for Climate Change, and Dr. Huma, Additional Director IPOs, from the development of the concept to documentation and excellent coordination with multiple stakeholders covering all areas of activities. And that has brought us together at this platform today to this high level for discussion. Thank you very much.
Thank you, sir, for framing today's dialogue with such vision and clarity, and for appreciation of our efforts. I now have the honor of inviting Professor Dr. Marcelo Nobel, Executive Director of World Academy of Sciences, to deliver his opening remarks. Professor Nobel is a renowned scientist and is very much known for the global advocacy he does for the strengthening science and research in the developing countries. Professor Nobel, we are delighted to hear from you.
Thank you. Thank you very much for this kind invitation. Distinguished colleagues, esteemed participants, and fellow advocates for scientific advancement in the Global South. It's my profound honor to address you at this virtual high-level forum on quantum science and technology, strategic pathways for the Global South. I extend my heartfelt gratitude to the Commission on Science and Technology for Sustainable Development in the South for this invaluable invitation to participate in what promises to be a pivotal moment in our collective journey toward harnessing the transformative power of quantum science for sustainable development. The opportunity to speak before this distinguished assembly represents far more than a welcome address. It embodies the enduring spirit of collaboration that has defined the relationship between TWAS and ComSats for over 3 decades. The partnership between our organizations traces its roots, as already mentioned, to the visionary leadership of Nobel laureate Dr. Abdul Salam, who founded both TWAS and ComSats, with a shared conviction that science must be truly global to address humanity's greatest challenges. Dr. Salam understood very well that the artificial boundaries separating nations must never constrain the boundless potential of scientific inquiry. His legacy lives on in every fellowship awarded, every research collaboration fostered, and every young scientist empowered through our joint initiatives. Since TWAS initiated the proposal for ComSat's formation in 1994, our collaboration has flourished into a robust partnership. Together, we have established PhDs and postdoctoral fellowships, shaped science and education policies, and championed science diplomacy as a bridge between nations. This partnership exemplifies the strategic imperative of building scientific capacity in the Global South, not as an act of charity, but as a forward-looking response to our increasingly complex and interconnected world. Today's focus on quantum science and technology is particularly fitting as we reflect on the history of scientific discovery itself. When Max Planck introduced the quantum theory in 1900, to solve the blackbody radiation problem, he could hardly have imagined how and that his revolutionary insights would eventually underpin technologies from lasers to computer chips. Einstein's explanation of the photoelectric effect in 1905, Bohr's quantum model of the atom in 1913, and the subsequent contributions from Heisenberg, Schrödinger, and countless others demonstrate a fundamental truth. Breakthrough science emerges from international collaboration and the free exchanges of ideas across borders. The quantum revolution was not the product of a single nation or institution. It was a global endeavor that required diverse perspectives, collaborative research, and the courage to challenge conventional wisdom. Today, as we stand on the threshold of the second quantum revolution, we must ensure that the Global South is not merely a spectator, but an active participant in shaping this transformative field. It is important to stress that local researchers are best positioned to address regional challenges and create opportunities for promising young talent. In quantum science, this principle takes on special significance. The applications of quantum technology, from secure communications to precision agriculture, from drug discovery to climate modeling, will require deep understanding of local contexts and needs. The quantum sensors that might revolutionize mineral exploration in Africa, the quantum communication networks that could connect remote communities in Latin America, and the quantum computing applications that could optimize resource management in Asia, just to mention some examples. These innovations will emerge most effectively from scientists who understand both the technology and the communities they serve. COMSAT's remarkable network of 27 member countries and 25 centers of excellence represents a vast reservoir of talents and potential. Through this network, we have witnessed remarkable achievements, researchers developing innovative solutions with limited resources, young scientists making breakthroughs, rediscoveries, and institutions building world-class capabilities despite challenging circumstances. These successes show that scientific excellence can flourish anywhere if given the opportunity. As we embark on this forum, we carry forward the conviction that quantum science and technology represents not just scientific frontiers, but pathways to sustainable development, economic growth, and social progress. The quantum technologies of tomorrow will require diverse perspectives, innovative approaches, and collaborative spirit that define our global South scientific community. Therefore, I am deeply grateful to COMSAPS for organizing this vital forum and for their unwavering commitment to advancing science and technology across the Global South. Your leadership in bringing together this distinguished group of people demonstrates the visionary spirit that Dr. Abdus Salam embodied when he founded both our organizations. The principles of equity, inclusion, and scientific excellence that guide COMSAT's mission align perfectly with TWA's commitment to building a truly scientific ecosystem. So let's move forward in the same spirit of collaboration that brought quantum theory into existence over a century ago. Together, we will forge strategic pathways that position the Global South not as beneficiaries of quantum technology, but as its architects and innovators. Thank you for this honor and for inspiring vision that you bring to our shared mission. I look forward to the rich discussions and collaborations that will emerge from this forum. Thank you very much.
Thank you, Professor Navel, for being with us and for highlighting the importance of advancing quantum science as a shared global endeavor for the Global South. So we now move to the technical presentations or the talks from our speakers. Our first speaker is Professor Dr. Galileo. He's the founding director of International Center for Physics in Colombia. Professor Valini has played a distinguished role in promoting quantum research and fostering South-South cooperation in advanced science for more than 4 decades. So, Professor, we look forward to your insights. Professor Galileo. Professor Galileo, can you hear us?
Yes, I was turning on the audio and the speaker and the video. First of all, I would like to thank you very much for this invitation. It's a pleasure for me to talk in this forum. As a matter of fact, I'm not an expert in quantum computing, but there are many things which I listened in the first two presentation, which correspond to a large extent to what I was going to underscore in my 10 minutes now here. It is true, the Global South must be an architect in this. It has been said by Ambassador Zacharias, it has been said by Marcelo. But the point is that we must be realistic, that this activity encompasses a lot of areas. And out of the areas, Ambassador Zacharias was very clear. Mainly, there are different areas in which quantum science, quantum technology is important, and unfortunately, some of them are extremely expensive because they require a strong infrastructure. Because it requires cryogenic the availability, which is not available in most countries of the South. This does not mean that the South should not consider this. But let's remember that it is true that we are today in the year of the quantum technology, but we are also in the year of the decade of science for development. And as a matter of fact, most of the applications which have been mentioned as important for quantum technology are relevant as other for the objective of for the goal of the quantum of the sustainable development. And this brings to the big question. We need not only to prepare people. It is true, we can prepare the people who can use quantum science, but we must also think to try to participate as much as possible in the big science, in the infrastructure creation of this. This brings me in two directions. One is how one can do that in the present situation in the Global South. In the Global South, we have a situation in which most countries invest very little in science, have a little capacity of investing. On the other hand, there are tremendous possibility of regional cooperation and interregional cooperation. One of the biggest mistakes would be if one thinks Latin America is a region, Middle East is another region, if Africa is another region. I think that what we much promote, and this is in line with the sort of Abdus Salam was one of my big mentors in my scientific life, and I think we should promote interregional cooperation through a joint action in these areas. As a matter of fact, let me mention one thing that I'm involved in this period. In this time, I'm involved very much in the promotion of the creation of a second synchrotron in Latin America. But we are in strong contact with the people in Iran, Uzbekistan, Puerto Rico, Africa, and we envisage a global program of light sources for the Global South. In the same spirit, I think one should think on a global program of development of quantum technology in the global south. Of course, if one looks at the application which are possible for the quantum technology, certain of these applications are very linked to immediate problems. Some were mentioned were linked to problems of agriculture, of food security, or of climate. So that really for this it is important that we create the human capacity to take advantage of this tool, which is becoming a tool which must be taken by all of us. But we must also be realistic on another aspect. We are facing a crisis of the multilateralism. We are facing a crisis of certain institutions, organizations, which were extremely powerful in promoting science in developing countries. So I believe that it is true that we must fight for developing quantum technology, but an action only oriented to development of quantum technology to create human capacity, which eventually has the risk of being either unused or to go elsewhere in the north cannot be the solution for the global south. So what I would say, my recommendation, and I know is in line with, to us, is in line of ICTP, is in line of Tom Sachs, is that we should really bet on the interregional cooperation and in promotion of actions which contribute to the establishment of big science infrastructure in the global south. I think that this is more or less the time I had. I see for me it's 4:28, and I have a time only until 4:30. So I think I'll stop here. Thank you.
Thank you so much, Professor Violani, for your stimulating contribution. This morning, I was reading one of the documents that you have you prepared, and it was published during 2016. It was an award, physics award, I guess. So there was a document which said how much the influence of Professor Abdul Salam on your life, from your first interaction to your participation in the Nathia Gali Summer School. So we would love to hear a lot of those episodes or interaction of yours. Yes.
I can tell you something more about that, because there is something which is not very well known about ComSat's history. In a sense, the idea of having a connection between different centers was one of the topics on which I often had discussion with Professor Salam. And in fact, I remember two moments, two milestones for this. One was a meeting of all the centers that Abdul Salam had proposed after his Nobel Prize, of which really one was ours, and unfortunately is still alive after 40 years. But also there was a meeting in 92 in Cartagena in Colombia, in which we advocated for a federation of centers, a federation of Latin American centers. And this, I remember, I wrote about this to the G97. It was a Pakistani was in this moment, if I remember well, the head of the G97. And then this matter was taken over again by me with Budinic. This was my only participation. But then a special environment Trieste was able to crystallize this idea. And in a sense, when I see Tom Sachs, I see also an outcome of ideas which have been possible in the tremendous atmosphere of international collaboration which Abdul Salam has created in Trieste. So this is another reason why I'm very happy to be here.
we are fortunate to have you as a CCC solution officer too. So inshallah, we will be having a frequent interaction with you and would love to hear more stories about your interaction with Professor Abdul Salam. Thank you so much once again, Professor Violani. It is now a pleasure to invite Professor Dr. Zafer Gedik from Sabancı University, Turkey. Professor Gedik is a leading authority in quantum information theory and computation with decades of pioneering research in the field. Professor Gedik, the platform is yours.
Thank you. Do you hear me?
Yes, we can hear you.
Thank you. Thank you very much. First, I would like to thank you for your kind invitation. It is my great pleasure to be in this meeting and to discuss such an important topic with our colleagues. It is, I think, by chance, I heard very good words about Professor Salam. I must mention my great experience in this Abdul Salam International Center for Theoretical Physics in Trieste in Italy, where I have seen him for several times for several years. As a student, physics student in doing his graduate studies, it was indeed a great pleasure meeting him, attending these activities at the center, because at that time it was really top in theoretical physics. I think this center and the contribution of Professor Salam shaped academic lives of many physicists, I believe. So I promised you to talk about this, preparing this human resources for quantum technologies, quantum computation, quantum information, and in other areas. I would like to just mention some experiences, my or our experiences in Turkey, and also possible modifications of our physics education or curricula to make us ready for this second quantum revolution. I have been teaching quantum mechanics for, I think, 30 years, but this is a standard teaching in the sense that the standard quantum mechanics course that we have been teaching in our universities throughout the world, everywhere. And basically, in this kind of courses, we teach our students the standard techniques, in some sense, the old quantum theory, 20s, at most 30s, and solving this fundamental equations for certain conditions. But the new revolution, the second quantum revolution, came later, where we have been using single units of quantum for communication, sensing, and hopefully for computation. We have now prototypes of quantum computers as well. And this, for us, and this was also for the country, a change at 2002. Where I have, when I moved to my current university, Sabancı University, I started to teach a course on quantum computation and quantum information. And we had only few students in universities who had interest in this kind of topics. This was more than 20 years ago. So we chose that strategy. We opened this course to all the universities in Istanbul. Istanbul is a big city, daytime maybe 20-something million population. So they came from different universities to our campus and attended this course. Now I see that after that many years, some of them are now professors working in quantum technologies in different universities in Turkey. And during this course, by the way, we worked on some new pedagogical issues. For instance, this quantum permutation algorithm, which is also known as Gedik algorithm, has been developed during this course. This is the simplest quantum algorithm that allows students to understand how quantum algorithms work. Along this, almost the same time, we started a series of conferences, national attempt, and they turned out to be an international conference on quantum optics and information. For 10 years or even more, we have been arranging this conference, and some of the experts, some of them are now, I think, among us, attended this conference as invited speakers. Also, students, young generations had chance to give their presentations, also meet with the experts. I think this also helped a lot to initiate the human resource, young generation working in quantum computation and quantum information areas. Another thing, I'm in so-called Village of Sciences, Foça, İzmir, a seaside city of country. We had another initiate here. This is called as Village of Sciences. It includes all kinds of sciences, but in physics part, we have been teaching mostly quantum mechanics, fundamentals of quantum mechanics, also some applications. And our first, or my first activity here was named as Other Quantum, in the sense that quantum, which we do not teach in our regular courses in universities. I think our colleagues now here who are physicists, who are teaching physics, know very well that things like Bell inequalities or Einstein-Podolsky-Rosen paradox were not among our topics in our curriculum or in our syllabi for quantum mechanics. You might also know this anecdote between Clauser and Richard Feynman. John Clauser, I think it was after his Nobel Prize 2022, or I don't know, I read somewhere, he meets when he was a young student with Feynman, Richard Feynman, a physicist and teacher. And he mentions, Clauser mentions his interest on Bell inequalities, and he mentions his plans to demonstrate this experimentally. And Feynman's reaction is, this is obvious what to show, go do the experiment if you want, but if you find something opposite or negative, then let's talk. So it was not an encouragement, just the opposite, discouragement by Feynman. I also had a similar experience when I was a student. And this was by chance when I was interested in Abdus Salam International Center for Theoretical Physics. One of my professors was there, and I mentioned my interest and on that kind of topics. This was before, Dorsey's algorithm and other things. There were no quantum computation and that stuff. He said, you see, Zafer, these are people who had some problems with Copenhagen interpretation. They try to find some loopholes. But I said, but there are some issues. These are interesting topics. And the talk ended in this way. After 25, unfortunately, we lost him afterwards. After 25 years or more, I wish he would see these days. Well, to wrap up, I think this is our experience in Turkey, in our institutions. And also, I think this is something we should talk about, maybe these modifications of our curriculum. And here, the main issue is what we called other quantum. So all kinds of Bell inequalities, quantum computation related issues like contextuality, entanglement should now be should take some place in our regular quantum mechanics courses, not only the course on quantum computation and information, but I think whole physics community now should have better experience in these areas. And I think this kind of meetings will be helpful in this type of initiations. So thank you very much.
Çok teşekkür ederim. Thank you so much,
Teşekkürler.
I was called Hojam because you are the teacher now. So thank you so much for joining us. Now we will have a recorded talk from Professor Osko, who has not been able to be with us online because he is actually conducting a summer school on quantum in the very remote village of Turkey.
Thank you so much for invitation of this very important event for the Global South that we should get connected because the challenges we face today in quantum technology also in the world are requiring global cooperation. And I think the organization of ComSat is playing a central role for this potential to be used. So what I want to contribute today is some of my personal ideas about how to train and ready next generation of quantum scientists, quantum researchers, and build some capacity to address these challenges. So I am from Koç University, and also I am affiliated with the TÜBİTAK Fundamental Research Institute. So I would like to start by first state the challenge we face in building required capacity for quantum technologies. So what you are going to see here, let me also turn on my highlighter here. So what you see on the right is some report from McKinsey and Company indicating that for every opening in a quantum technology related job posting, there is a not sufficient number of applications. So the ratio is like 3 to 1. So if there are just a lack of talent significantly, like 33%. So we have to train a lot of people actually to catch up and fill in this gap. So what kind of solutions are considered is that while waiting for the actual quantum experts or quantum engineers, we can train the related disciplines, like maybe in electronic engineering, maybe in chemistry, computer science, and so on. Or we can even use high school students or undergraduates and just design some certificate programs like quantum software certificates. And we can also consider merging some related departments or open some minor and track programs. I can give you one example from my own institute. So next year we are going to start a quantum technology track specialized in integrated photonics and photonic computations. So this is, we are very excited with this. And we are also trying to establish some links with international schools to start some joint graduate programs on special designed quantum technology issues. So our school is very good at optics. We have very strong optical laboratories and some experience in quantum tech, and we want to collaborate with other departments because as you see, or as you know already, that the training of quantum technology is highly interdisciplinary and highly global effort actually. So to start such an effort, you need some funding, you need some planning, and this requires convincing policymakers and the decision makers. And for that aim, it is a long tradition. Actually, I'm very grateful for Pakistan for this training such an excellent person, excellent researcher, scientist, Mohammed Sohail Zubari. He was the very first speaker that contributed and made it real that our quantum optics and information meeting held in Ankara in 2016. Then it started a very good tradition. We never stopped even during the pandemic sessions, and every year in different city in the country, we organize such a meeting, inviting experts, and simply shake the people and remove them from their comfort zones, so that even if they are in a related field, they can start doing research in quantum technologies. So now we are reaching a highly critical mass. We have started with a handful of people, but now nationwide we have generated very good attention, very good awareness, and many people are now doing quantum technology research. So we have not always addressed, of course, the academicians. As I said, we need policymakers and decision makers, even companies, to give some funding and effort. and even open some task forces in their departments, in human resources, in their job or research and development departments, make some openings and at least study some use cases about the potential of quantum technologies. So I gave talks, these are Turkish unfortunately, but basically one of the talk like in quantum technologies used in finance. And I gave this talk to lots of people from banks and finance sector. I also gave talks to telecommunication sector and different industrial experts to create some attention of them, and they really liked the idea. And to generate an ecosystem in the country, they started to build up some task forces actually in their own departments and companies. So of course, in addition to that, we have to make sure young people will be attracted towards that kind of research. So in our countries, Pakistan also I know like that, we have a huge, very curious and young people that are very curious about modern developments in science, and they are very open-minded. So we, to attract them to these modern developments in the world, in the landscape of quantum science, we organize some science fairs, open some quantum theme parks, basically some applications, attractive applications and games based upon quantum principles. And we also open some workshops, also design some prizes like best poster award on some research topic on, like you see some example here, industrial applications of quantum computing. And another example, like some quantum game based upon quantum entanglement and that kind of things. So these are, especially at the undergraduate level, generate some attraction in the young people. This Technofest is one of the biggest events in the country that has not only quantum but many different technologies presented there, and lots of competitions and awards are given. So in the last 2 years, they are now giving awards to quantum technology hardware development and some near-term quantum computer applications. Well, after this awareness is generated, not only in policymakers, but also in the young people, in the academia, what you need is to guide this awareness by some funding and some opportunities to generate interesting projects. So TÜBİTAK plays the key role in this. For instance, if you want to organize a conference, if you write a project, you can allocate some of your project funds for dissemination and organize a conference on your topic. And universities are very generous. They allow you to use their, especially state universities, allow you to use their facilities, conference halls, seminar rooms, and so on, free of charge. They even, depending on the season, they can give you dormitories and so on, even some other facilities. And TÜBİTAK also has some centers like Informatics and Information Security Center, Bilgem, and the one that I'm affiliated, TÜBİTAK Basic Science Research Institute, and also the Nation Methodology Institute. They also organize lots of conferences and workshops with participants can just join without any expenses, basically. Well, I am also happy to see there are many bilateral calls, and some of them are including some Pakistan scientists and organizations as well. And TÜBİTAK for this has special grants, which organizing bilateral or even multinational conference events. So you can apply them through TÜBİTAK grants and finding some partner in the country. Also, I think there is a very good relation between the Higher Education Commission of Pakistan and the TÜBİTAK, that they organize bilateral calls, and such funding is available also for organizing different scientific events, also for projects too. Of course, for projects, in order to make this in the landscape of the quantum technologies, it took some time, but now it is one of the high priority research topic in the Turkey. So we have in our national development plan, quantum technology is playing a role here. So you can see that this quantum technology and photonic, this means photonic and quantum technologies, is one of the high priority topic in our development. So in addition to that, there are attempts to develop more sector-oriented plans, like a defense sector, public sector, medical sector, etc. And there are now targeted project calls on quantum technologies, also bilateral international project calls, with also including the European Union projects also. Well, so once you have, of course, awareness and some understanding of the potential of quantum technology, and also you have funding and wrote a project, you write a project, of course, you need a team to run this project. And this is where the problem actually surfaces. That is the topic of today's discussion. So even if you have money, even if you have hardware, even if you have awareness in the public and the policymakers, you need a team to run these ideas and make them real. So now this is not only a problem that we face in Turkey or in Pakistan, but it's a problem globally that we are facing, as I mentioned at the very beginning of the talk. And people even discuss, can we use high school students to fill the gaps? So there is some discussion to convert to K-12 to Q-12 by adding some quantum components, because when you are already in the undergraduate, it is very difficult, because in classical training or standard training in high school, quantum concepts are never heard normally. So it is like a very big cultural shock when undergraduate students face the quantum. And therefore, to give this highly weird concepts of quantum mechanics earlier age can be, it's like a new language, and people can learn it even more efficiently if you start earlier. So there is a lot of discussions about that at the educational literature. And also they want to use some, because it's very difficult to understand abstract concepts of quantum, they want to use some hands-on training in this early years, like realizing this potential. Several companies are developing desktop quantum PCs that can work in room temperature. They are developing some experimental entanglement type of demonstration that is suitable for introductory physics courses, even at high school level. Well, in Turkey, TÜBİTAK, of course, played a central role, and they realized that it's not even sufficient to train the students, but we have to train the teachers. So TÜBİTAK, with some private university, as university in Turkey, started a program to train high school teachers on quantum technologies. And at Koç University, we have also started some quantum technology training programs in the summer research program. It is integrated very well. And also my affiliated institute of TÜBİTAK, this is the TBAE, which is the Fundamental Science Research Institute. We are organizing summer and winter schools online so that we can access many students all over the nation. Well, in addition to that, undergraduate and high school students can join societies like Quantum World through Quantum Turkey. Quantum Turkey is a branch of a global society known as Quantum World. It is offering some certificates based upon IBM Qiskit, which is a quantum programming software that you can run on a cloud, on a quantum computer, or in a quantum simulator. So they give you different levels of certificates, bronze, gold, platinum, that kind of different levels of teaching. And after you get your certificates, you can join some team. And then there are very big prize hackathons that you can work out in an industrial type of near-term quantum computing problems. And today, actually, I am currently, when I'm giving this talk currently, I'm in campus at Koç University. But when the ComSat event is happening, I will be in a spare position that I will be actually in a science school. That is the one that you are seeing on the left. So we have some science schools or boot camps that we select very high level students from high schools or advanced undergraduates, and give a 1 or 2 weeks of highly concentrated and dedicated teaching on different advanced topics, like I taught last year quantum thermodynamics, and this year I'm going to teach some quantum signal processing, and more fundamental level also we teach some courses. So these are very efficient because it's a face-to-face interaction with experts for the people, young people from all over the nation. And normally in universities, we teach standard textbook problems, but here we teach more advanced topics. Of course, to convince people that quantum technology education is useful, you need to develop a well-defined program. And the topic is very interdisciplinary. And also people may not know what to do after graduation. After all this knowledge, can they find a good job? So it is also necessary to train industry, human resources, what kind of skill set they need and what's the potential of this kind of people. So this is also taking some time, of course. So as a conclusion, I can say that capacity building is as critical as developing this hardware for quantum technologies. And people are discussing this even from high school level to graduate level. And the competition is also not only on who will build the best quantum computer, but also who will train the best quantum engineers and scientists, but also who will give them a good living conditions to maintain this talent, because there will be also some kind of competition to attract this talent from one place to the other. And I think this is a global problem, and like European Union or societies like ComSat are realizing that that this requires some non-local effort, global effort, or some reasonably localized effort, which international collaboration can be key to maintain and share this talent pool. So thank you so much for your listening. I would like to end my talk, also give my special thanks, and also maybe 2 examples that I can give you that I contributed a little bit to capacity building, that Mohammed Tahir Nasim and Ashkarullah are excellent students that joined me from Pakistan to my group. Mohammed graduated in 3 years ago and now currently returned back home to Pakistan and works on quantum technologies, writing projects and contributing to the quantum technology in Pakistan. And Ashkarullah will hopefully graduate this year, and he's an excellent student, wrote a lot of papers and brilliant ideas, already contributed to the field. So thank you so much.
So we are really thankful to Professor Osko, who managed to send us the recorded talk at this time of the semester when he's working in a remote village. Before inviting our next speaker, I would like to add a few things. One, that the audience can pose the questions in the chat box, or raise hands during the technical post-technical session, after the technical session, during the discussion. And the second thing that we will try to share the link of the recording of other than ComSat YouTube channel. We will share the Zoom recording link with the audience as well, and the certificate of participation will be issued to the participant as well. Now, our final technical presentation or talk will be delivered by Dr. Hamid Raza Mohammadi from University of Isfahan. Dr. Hamid Raza work advances quantum communication and computational methods with implications for both academia and industry. Dr. Hamid Raza, the floor is yours.
Thank you. Good time for everyone. Thank you for your introduction. Thank you for your invitation. First and foremost, I would like to express my gratitude to the organizer of this meeting for the kind invitation and for providing me with this opportunity. I'm going to start with it. Okay, in this time, with the profound sadness, I extend my deepest condolences for the tragic loss of so many precious lives in Pakistan devastated flood. May those who grieve find strength in this difficult time, and may the survivors be granted patience, resilience, and resource health as they rebuild their life. My name is from the University of Isfahan. I apologize because my English is not very effective. I have already prepared the presentation text. I will share our perspective on a critical issue, building human capacity in quantum research perspective. A perspective for you. I will structure my talk as follows. I will outline the essential ecosystem needs to support the quantum technology, and the core of my presentation is detail Iran's vision and the specific challenge we face, particularly due to our geopolitical situation. Finally, I will offer suggestions for solutions that I believe are applicable not just to Iran, but to many nations in the global south before opening the floor for discussion. Why quantum technology is important? Quantum technology utilizes fundamental quantum phenomena, including superposition, entanglement, discord, interference, and indistinguishability, to address challenges that are intractable for classical systems. This quantum resource enables breakthrough in optimization, factorization, ultra-persistence beyond classical limits, and probabilistic communication. So why this field is crucial? Firstly, the economic potential is enormous, with projection reaching to about $2 trillion by 2035. Secondly, and alarmingly, the research is, I thought previous slide. And alarmingly, the research is currently concentrated in a few geopolitical blocks, creating a new quantum divide. For the rest of the world, this is not just an economic issue, it is a profound national security concern. And the third reason is the security. The purchase security is not secure, is not safe. The security industry's products, including both hardware and software solutions, are not truly secure when commercially purchased as a standalone offering. By the very nature, security systems lose their security and safety when created as commoditized products rather than native solutions. In the next slide, I present a quantum. Next slide. Okay. When we talk about quantum technology, it is not single thing. It is an umbrella term encompassing powerful domains: quantum computing, quantum sensing and metrology, quantum communication. Accelerating advances in quantum technology are powerful reminders that the technology is rapidly advancing towards commercial viability. Next slide, please. Building a quantum capability is not just about building a lab. It is required a holistic ecosystem. This is a trade-off collaboration between universities, government, and industry. Universities for fundamental research and education, government for strategic funding, and industry for development and commercialization. Orbiting this core are essential elements. Modernized education, critical infrastructure, informed policymakers, and collaborative quantum hubs that bring everyone together. Without this interconnected system, progress is fragmented and slow. In the next slide, the ecosystem of quantum technology and quantum science in Iran is presented. Please next slide. Okay, in Iran, Iran's quantum technology ecosystem shares this common structure. The academic sector is governed by Ministry of Science, Research and Technology. Over the past decade, several Iranian universities established quantum roadmaps have successfully informed policymakers about the field's strategic importance. This advocacy led to launch of a national quantum mission. This vision is driven by multi-stakeholder approach. The Ministry of Science, Research and Technology oversees academy, while Vice Presidency for Science and Technology fund knowledge-based companies and startups. In addition, INSF, Iran National Science Foundation, supports fundamental research. Contribution also comes from charitable donation and other entities. Furthermore, the industry sector has pledged its support to the mission. This multi-pronged strategy is essential for mobilizing the necessary resources. Please, next slide. To give more concrete examples, the government funds and support. Crucially, we are establishing physical quantum hubs, like one in Shahid University of Tehran and here in Isfahan. These hubs are designed to central nodes that concentrate talent, equipment, and research efforts, preventing duplication and fostering collaboration across the country. Like a USB hub that connects and powers multiple peripherals, a quantum hub serves as a centralized platform providing shared resources and service to universities, research institutes, and students across the country. These hubs serve multiple critical functions. Next slide, please. Next slide, okay. They are first and foremost a physical home for community, students, academic, and startups. They provide fundamental labs for education, like performing Bell inequality tests, a rate of fascinating quantum optics, a key role in the compact brain by offering postdoctoral and PhD support, providing a career path here at home. They also focus on developing tangible products like quantum key distribution, quantum imaging system, high precision sensor, and so on. Ultimately, they offer complete package, financial support, access to high-tech labs and collaborative environments, and most importantly, a pipeline for a student's idea to train execution in the lab. All of this effort is directed towards one ultimate goal, achieving scientific authority, not just following, but leading. As this pyramid illustrates, this authority is built off a foundation of technological sovereignty, or own lab, or own product, or own domestic security. Upon that, we build the pillars of inquiry, development, and investment, and the peak of the most valuable asset, deeply expert people who drive innovation. In this slide, I talk about the challenge for Iran. In Iran, the challenge, we have three issues for education, funding, and human capacity. However, our path is fraught with significant challenges. In Iran, students must pass through a filtering process called a concourse university entrance exam to enter university. This screening mechanism determines the distribution of a student across various academic fields. In the concourse, a student competes with one another to secure a spot in top-ranked disciplines, and as a result, they often choose their field of study not based on interest or talent, but rather on their performance in the exam. Consequently, many talented students, despite their true aspiration in pursuing medicine, rather engineering or basic science. In education, or curricula are theoretically sound, but often not in practice, and severely lack hands-on practical training. In the funding section, funding is a major constraint due to interaction sanctions, which also create a lack of global customer base of any product we develop. This all culminates in our biggest challenge, human capacity. We are in the constant battle against brain drain, the rapid loss of our bright talents to other countries where opportunities seem greater. Next slide, please. There is some suggestion for solution, such as technical training, hands-on adopting curricula, interactive course, or mitigating the effect of sanctions with the help of our alliances, such as BRICS, ECO, or other NGOs. Networking or promotional to mitigate the problem of concourse exam. Next slide, please. In conclusion, quantum technology presents a dual reality for global souls. A monumental opportunity for passing the challenge, and a formidable challenge. Due to research constraints, the foundation for navigating this human capacity building, the time to act is now. We must integrate modern curricula with hands-on training and forge a strong international network. We can implement mechanisms like a scholarship bonds where stand funded by state commit to working critically for a period. Every nation needs to question quantum strategy with clear human capacity targets. And we must leverage partnership with each other and with sympathetic organizations to accelerate our progress. Our collective security and economic future depends on it. Thank you for your patience and attention.
Thank you.
Thank you, Dr. Hamid Reza, for sharing your valuable expertise and the presentation, which have highlighted a very significant pointers for us for human capacity development in the quantum science. So we now open the floor for the question and answer. I have received one question from Mr. Osama, a young participant. He asks, given the widening quantum divide between advanced economies and the global south, what immediate policy or capacity building measures do you see as the most practical for your country or for any developing country in the global south, whether in higher education, research funding, or industry partnership, to secure equitable participation in the quantum era? So the question is for any speaker who would like to share their insight. Professor Zafir, Professor Galileo.
Well, thank you. Shabaher, Professor Hamid Reza. I think there's one point you raised in one of your slides, which is, in my view, extremely important. The idea of a circulation among of young people in the global south. I mean, if you think that in Europe the Erasmus program has been of tremendous importance. Now, if one is able to have schools in which one can move, one can put people from developing countries staying together, this I think can be a big opportunity. To some extent, this happens in Trieste at ICTP. One of the great advantages of ICTP is that it is a kind of accelerator of international relations in the South. But this can be one can start very early at the level of PhD students with selected activities, and I think ComSats perhaps could play a role for that.
Indeed.
Professor Zafir?
Thank you.
Hello. Actually, I have thoughts on very similar lines, but I should add the importance of the support for education, because still on this side, both in application and in theory, this year, don't forget, is International Year of Quantum Science and Technology. We need both types of, educations, and we need to, as I said during my talk, just renew our curricula. So the answer to this question is, of course, we should have national quantum initiatives. Most of the time, these are on, establishing national centers for quantum technologies. This is for sure we need it. But also we should have some new plans to educate the necessary, staff for these research centers.
We have received one more question from the audience. It's Rahil Masood, and he asks, how can the Global South leverage international cooperation in quantum R&D to address specific maritime challenges such as optimizing port operations, shipping routes, predicting ocean currents, or enhancing marine environmental monitoring. So this marine environmental monitoring is very much of interest to the COMSA Center for Climate and Sustainability too. So any speaker would like to shed some light on how we can leverage international collaboration in quantum R&D related to these areas? Professor Hamid Azal, Professor Galileo. Professor Zafir, if you would like to answer these questions, or
Well, in my case, my experience in my country is that I had contacts with several companies. The biggest petroleum company of the country, the Turkish Airlines, and some transport companies, and also some car companies. Their interest, current interest, is mostly this time of optimization. And in quantum technologies, if we just look at the practical applications, the number one application that is commercially available is quantum key distribution. This is important. But the other one is these optimization machines. I think we need to have some access to this kind of machines. We have some international companies, but it is not always possible to reach these machines, or even sometimes to have education. I learned this from one of my colleagues. So I think this can be a strategy, if not to construct proper machines that can do this kind of optimization stuff, at least to have some connections to facilitate this access of the companies or people in general to this new technology.
Right. Thank you.
Professor Galileo, if you would like to add something?
Yes, I must say, concerning the specific question, I am not an expert and I don't have an answer, a specific answer. But the main point is that the problem of the South is not a problem of single question, it's a structural problem. It's the problem of that even if a problem exists in a country in the South, that country will look for a solution in the North. I think that what one must strengthen is the South-South relation, but this cannot be theoretical. If people don't know each other, if people don't communicate, it is unavoidable that you go to the North. Now, in my view, one must be also very careful on certain things. You know, UNESCO has proposed very much the problem of open science. Open science is important, I agree, but we must understand each other what we mean by open science. It is not only to have access to science, to have the possibility of using science. For this, the North is sufficient, and then the South is a user. One must have the possibility of participating in the building of science. And in my view, if one does not face this aspect of the general science policy of the South countries in 10 centuries, I'm afraid certain countries in the world will be still discussing the same thing we are discussing now. Of course, I cannot check, but if you take a note, in 10 years or 20 years, you can check.
Dr. Huma?
Yes.
I
Yes,
think
Dr.
we
Marish.
have a participant who wants to himself.
Sorry, Dr. Marish, can you speak again, Dr. Marish?
We have one participant who wants to ask a question himself. I've asked my technical team to check if he can give him access.
Okay. Ali Hamzat, you can unmute yourself and ask the question.
Oh, thank you. Thank you very much. I hope I'm audible. Am I?
Yes,
Yes.
you are very much audible.
Great. First of all, thank you, concepts and respected speakers. My question might sound a little naive, but I think it's important to ask that in a country like Pakistan, where it's my personal observation that the love for science has faded with time a bit. So don't you think that it's about time we kickstart some meaningful science communication projects where scientists talk to non-scientists and create a love and passion among children and youngsters about science, particularly in physics, if we talk about. And it can help us, I mean, the science communication projects might help us to come out of our silos and connecting with society and inspiring young, bright minds. What's your take on that? Anyone, please.
Professor Galileo, Professor Zephyr, would like to address the question?
It is a point. This point is a very interesting point because, in fact, it actually there are two aspects in these questions which are joined together. One is the need of communication, and communication for what? For developing more financing, more development, and so. And for that, it is essential. It is essential that countries develop also some experts in journalism. I mean, the idea that a scientist must communicate science is to some extent naive, and for two reasons. One is that because a scientist is also a conflict of interest in developing. I mean, to propose that we invest in new idea may mean in a difficult situation that I am accepting to reduce my financing. So therefore, I believe in the science community, but it is a community which must be taken with caution. Instead, so one basic point is that you cannot have a development of science in a country without the support of the civil society. This is a fact. But for this, you must also create conditions through a promotion of journalism, of scientific journalism of quality, and of course, then the scientific community contributes to this. But the idea that it is a responsibility of scientific community, in my view, is naive.
Thank you, Professor Galileo. And what I could extract from this answer and question session that we, without extending, overextending limited resources we have for the global south, we need to build a niche expertise, and it will definitely pay off in the future for the global south. So as we bring this forum to a close, it is my privilege to invite Dr. Mavish Durrani, Director and the Head of COMSET Center for Climate and Sustainability, to deliver the vote of thanks. Dr. Mavish, over to you.
Thank you, Dr. Uma. Thank you very much, my team. And I think we have a few more questions here from the participants, but I would request my worthy speakers and of today's event that maybe they would like to answer us after the event on these questions so that we can address these issues and we can share with the audience. And because of the time constraint, I think we will just wind up our session. So I would really like to formally thank everybody who has been attending this event today, and our distinguished speakers, colleagues, and especially my resource persons and speakers from all around the globe. And on behalf of COMSET Center for Sustainability, I extend sincere appreciation to all those who contributed to the success of this high-level forum on quantum science and technology strategic pathways for the global south. I thank our speakers, Professor Dr. Galileo, Professor Dr. Zafar from Turkey, Professor Dr. Ozer, Dr. Hamid Reza from Iran, despite the situation in Iran, is attending the event, for their valuable insights, which highlighted both the opportunities and responsibilities associated with advancing quantum science in the global south. We are also grateful to Professor Dr. Marcelo Nobel, Executive Director of TWAS, for his thoughtful remarks on the role of international collaboration in strengthening scientific progress. To all the participants, scientists, academia, and experts, your engagement has added depth and relevance to today's discussion. I acknowledge with gratitude Ambassador Dr. Muhammad Nabi Zakaria, Executive Director of ComSets, for his guidance in convening this forum. I also thank Dr. Homa, my team member, Mr. Babar, Ms. Sherbano, and Mr. Zakir for their support in organizing this event. And in closing, let us take forward the spirit of collaboration fostered today to ensure that benefits of quantum science and are accessible, inclusive, and aligned with the need of the global south. And in the end, I also want to thank my technical team for being with us and for making this a successful event. And we are really looking forward to have much more such interactive and intellectual events in future where we can engage our worthy speakers again. Thank you very much. Thank you very much, everyone.
Thank you, Dr. Mavish. Thank you all participants. With this, we come to the end of the event. We are really thankful to all the participation and the support from the ComSet Centers of Excellence, especially who have been with us today. To all the speakers, have a very good evening.